Okay, today's lesson is on section 1.3, which is solving by factoring. Don't forget to do your warm-up exercises. These are things you're going to want to FOIL. Even number 3, you're going to need to rewrite that and then FOIL it. And number 4, you're going to want to set that up as a quadratic. So make sure that you're using both components and you're FOILing when you're multiplying. Example number 1 is to factor the trinomial of the form x squared plus bx plus c. When you look at your trinomial, you want to see two sets of parentheses, 1x plus m and 1x plus n. And the goal is really to find the correct m and n to solve the equation. So in this case, m times n is going to equal our last term, which is positive 20. And m plus n is going to equal our middle term, which is negative 9. And I know that because when I FOIL this equation, I do my first terms, x times x is x squared. So that's correct. I do my outer terms, x times n, my inner terms, x times m. So those two are going to have to add up to be that negative 9. And then I do my last terms, m times n, and I know that has to be 20. So I need to think about factors of 20 that will also give me a sum of negative 9. So factor pairs are 1 and 20, and 4 and 5, and 2 and 10. So when I think about adding any set of those factors, the ones that add up to 9 are 4 and 5. But 4 plus 5 doesn't equal negative 9. So I'm going to need to use a negative 4 and a negative 5. That tells me negative 4 plus negative 5 equals negative 9. And two negatives multiplied together equal positive, so negative 4 times negative 5 is positive 20. So now that I have that information, I plug it back into my formula, x minus 4 times x minus 5, and that's going to be my equation factored. Now the reason I want to factor is because then I'm going to have to solve for the 0 values or the x values. If you want to check your work, you can just FOIL. X times x is x squared. X times negative 5 is minus 5x. Negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20. I combine like terms, and I get x squared minus 9x plus 20, which is what I wanted. So we're all set with that example. Letter B is a similar example. In this case, m times n needs to equal negative 12, and m plus n needs to equal positive 3. So again, I think about the factors of 12, 1 and 12, 2 and 6, 3 and 4. And then which sets of those factors are going to add up to be positive 3. When I look at this, none of these factors here, 1 and 12 can combine to be 13, 2 and 6 are 8, 3 and 4 are 7. None of these equal positive 3. And so this equation cannot be factored. This is when we would use the quadratic formula, which you memorized for your gateway exams and may have forgotten already. But if we have something where we take the factors of mn and none of them can be the sum of m plus n, then it doesn't work. The equation's not factorable. So in terms of special factoring patterns, we have what's called the difference of two squares. So anytime you see a squared minus b squared, you can immediately factor that as a plus b times a minus b. That's just something if you memorize, it's going to help you learn to factor really fast. So an example of that would be x squared minus 4. Right, 4 is a perfect square, so that's why my b squared just looks like 4. That will factor immediately to x plus 2 times x minus 2, because 2 is the square root of negative 4. Another example of a good factoring pattern is the perfect square trinomials. Ax squared, a squared plus 2ab plus b squared is going to equal a plus b squared, and a squared minus 2ab plus b squared equals a minus b squared. So again, these are just simple factoring patterns to help you memorize so you can factor a little quickly. So an example would be x squared plus 6x plus 9. 9 is a perfect square, so I can rewrite that as x plus 3 squared, right? And if you FOILed that out, you would get x squared plus 6x plus 9. Another example, x squared minus 4x plus 4 is the same as x minus 4 squared. Sorry, x minus 2 squared, because 2 is the square root of 4. The next example is to factor each expression. These you can definitely use those key rules that we did before. The difference of two squares, a squared minus b squared, is just a plus b times a minus b. So a squared minus b squared is the same as a squared minus b squared, right? 49 is the same as negative 7 squared. So I can rewrite this as x minus 7 squared. And letter B is just factoring a trinomial. So 36 is a perfect square. So all I need to do is d plus 6 squared will give me d squared plus 12d plus 36. You really just want to look at what the perfect square is in that last term and use the square root of it. And if I looked at this and I FOILed it out to check my work, I would have d squared plus 6d plus 6d plus 36, which is the same as d squared plus 12d plus 36. And I have the same answer. The next property we want to look at is the zero property. The zero property basically says that if x plus a times x plus b equals 0, then one of these terms must equal 0. So either x plus a or x plus b is going to equal 0. They could also both equal 0. And that just helps us to remember that if we wanted to set either side of these equations equal to 0, we could actually solve for x. Then we could say x equals negative a, or the opposite of a, or x equals the opposite of b. And we'll do an example. So what are the roots of the equation x squared minus 5x minus 36? First we want to factor. So x squared minus 5x minus 36. Again, I need an m times n that equals 36, and I need an m plus n that equals 5. So factors of 36 can be 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 times 6. Okay? Any of those pairs that can combine in any way to be 5. Well, 4 and 9 will be 5, but they need to subtract, which is also fine because I get a negative 5, right? Negative 5, negative 36. So when I combine, x should be minus 9 times x plus 4, because a minus 9 and a positive 4 would give me a negative 5, and a minus 9 times positive 4 would be negative 36. So I factor my answers, and then I need to solve for the zeros. So I can say x minus 9 equals 0, and also x plus 4 equals 0, which tells me x equals 9 or x equals negative 4. Example 4 has us looking at solving for an expansion of a field. We're going to go over this one in class because there are a lot of steps, so we will talk about it next class, so you can skip that on your notes. Example 5 says find the zeros of the function by rewriting it. Again, this is something that you can just factor out. Mn needs to equal negative 12. M plus n is negative 1. Right away, I know that's going to be 3 times 4. So x minus 4 plus 3. And if I solve, I can say x minus 4 equals 0. So x equals 4. And x plus 3 equals 0. So x equals negative 3. Last thing you're going to want to do is your daily homework quiz. Don't forget to show all of your work. These are just factoring. If you can use any of the shortcuts, like the difference of two squares or perfect square trinomial, please do so. You do not have to do number 4 because that has to do with example number 4, which we're going to cover next class.